we're going to analyze this circuit using mesh current analysis, and we're going to do this by inspection. So here I have assigned my mesh currents IA, IB, and IC, and they're all in the clockwise direction. So let me show you how to do this inspection. Let's start off with mesh A. Okay, first we look at R1 and see what's in common. The only thing in common is just IA. So we have IA going through R1 and R2. So R1 plus R2. And we're doing a KVL equation. We're starting here. We're going through R1, R2, and VS2. Okay? So we have this. Now look at R2. We also have IC, but it's going in the opposite direction. So we have minus IC R2. And then we see that VS2 is consistent with the direction of IA, so it's a plus VS2 is equal to 0. So that's for mesh A. For mesh B, I'm going to do the same thing. We're going to start at this point, so we're going to go through a minus VS2, R3, and R4, and we see that R4 and R3 is consistent with the direction of IB here. So what we have is R3. What's in common with R3? It's IC and IB. Well, first we'll write down the currents for IB. IA does not go through here, so what we have is IB is R3 plus R4, but we also have a minus IC R3, and then this is a minus VS2, which is equal to 0. So that's for mesh B. For mesh C, okay, we have R2, R3, and VS1. So here we're going to a positive VS1. Okay, is going through R3. So IC goes through R2 and R3. So it goes through those elements. But then let's see what's common with R2. So we see that it's a minus IA R2 and a minus IB R3, and that's equal to 0. Now let's arrange this in standard form. So we'll put all the diagonal terms IA, IB, and IC as positive, and we see the coefficients associated with IA is R1 plus R2. The off diagonal terms, we have a minus R2 here for IC, and that's equal to VS2. So we have a plus 0 IB. Now for mesh B, we have R3 and R4 plus R4. We have a minus R3 for IC, so that's a minus I3 IC. And then we have a positive. This is a negative VS2 in the first equation, and this is a positive VS2 in the second equation. And we have 0 IA. And then finally for IC, we have R2 plus R3. We have on the off diagonal terms minus R2. Let me clean this up. R2 IA and a minus R3 IB. And that's equal to a minus VS1. So that's our equation in standard form. So if you notice the pattern associated with this circuit, we start off with IA and we see what goes through IA, since we're dealing with IA. So we have resistor R1 and R2. What's common in RA is IC for R2, so that must be a minus R2 IC. Then we look at IB. here for our second ones, and then we know it goes through R3 and R4. There's no IA common in here intersecting this except for VS2, but we see what's in common for R3 is a minus IC. And then finally for IC we have going through R2 and R3 right here, and then we have a minus IA because that's what's common through R2, and then R3 we have a minus IB. So that's why we have a minus I3. So we put this in matrix form. We can almost do this by inspection. So we have R1 plus R2 for IA. We have a no common current with IB, and we have a minus R2. Next we have 0 IA, and then for IB we have R3 and R4 going through R3 and I4, and then we have a minus R3 since that's for IC. Then finally in the last one we have it, IC goes through R2 plus R3. We have a minus R2 for IA and a minus R3 for IB. So that's our matrix for our circuit associated with that, and then we have multiply it by the unknowns IA, IB, and IC, and that's equal to our voltage sources. In this case it would be minus VS2 plus VS2 and minus VS1. Okay, so here when the let's say VS2 is in the same direction of IA, then it's a minus VS2. Here VS2 for IB and VS2 and IB are opposite direction, so we have a positive VS2. We have IC in the same direction with our polarities of VS1, so that's a minus VS1. So just think of the voltage source. If they're in the same direction, it's a minus VS1, minus VS2 since they're supplying voltage, and if they're opposite, then it's a positive VS2. For in this case, it would be for mesh current IB. Now let's assign some values to this circuit that we just did by inspection. Here we have R1, R4 equals to 2K, R2 equal R3, which is equal to 4K. So we'll just substitute here. So R1 plus R2 is equal to 2K plus 4K, and then we have 0 here. Minus R2 is just minus 2K. We have a 0 here. Then R3 plus R4, which is 4K plus 2K. So it's 4K plus 2K. Then a minus R3, which is just a minus 4K. We have minus R2, which is just minus 4K. Minus R3, which is minus 4K. And then finally we have R2 plus R3, so that's just 4K plus 4K. Multiplied by the unknown mesh currents, IA, our vector of unknown mesh currents, which is equal to the voltage sources of minus VS2 plus VS2 and minus VS1. And then completing this arrangement here, we have 6K, 0, minus 2K, 0, 6K, minus 4K, minus 4K, minus 4K, and positive 8K. IA, IB, IC equals minus VS2 plus, 1, VS2 and minus VS1. There's 2 here. And that completes this analysis in terms of describing how the circuit is in terms of the mesh currents.